Dear students, under the lecture series on complex analysis, we are going to commence with complex integration, under which we are going to learn about definite integrals as the first topic. So the problem here says that show that integral over c modulus of z the whole square dz is equal to minus 1 plus I, where c is the square with vertices 0, comma 0, 1, comma 0, 1, comma 1 and 0, comma 1. So first we shall draw the region, that is the square, with these vertices. So first let me point the first point O, which is 0, comma 0. So we are plotting the points. So this is the point O, which is 0, comma 0. Next we have A, which is 1, comma 0, which will be somewhere here, this will be 1 units in x, and the value of y is 0 over here. So this is 1, comma 0. Okay. And similarly, the next point is 1, comma 1, which will be somewhere here. This is 1 and this distance is also 1. So 1, comma 1. And the last point C, which is 0, comma 1, where x will be 0 here and y will be 1 unit. So this is point C and this is point B and this is point A. So we have plotted the points. Now we may join these points in order to form the square. So the required region C has been divided as 4 straight lines. That is, let us take this straight line as C1 and this straight line as C2. That is AB as C2, and then BC as C3 and OC as C4. So the region C can be written as the sum of C1 plus C2 plus C3 plus C4. So that we have written, so that is C equal to sum of all the 4 line segments, where C1 represents OA and then this AB and then BC and then we have OC. So these are the line segments. Now in order to evaluate this integral over the region C, it is sufficient for us to find the value of this integral over the line segments C1, C2, C3 and C4 and add all the 4 integrals in order to arrive at the required result. So first we shall evaluate for the line segment C1. Now we are going to evaluate the integral over C1, that is this line segment first. Now we have to understand first of all what is this line segment C1. It is the line OA. So what are the points that join the line OA? That is, O is 0, comma 0 and A is to the point A is 1, comma 0. Now we want to find the parametric equation of the line segment C1. Now in order to find the parametric equation of the line segment, we know that the parametric equation of a line segment joining 2 points is given by, that is, for example, if we consider it as point x1, comma y1 to the point x2, comma y2, then the parametric equation are given by x equal to x1 plus t multiplied with x2 minus x1. Similarly, y is equal to y1 plus t multiplied with y2 minus y1. So these are the parametric equations of a line segment joining 2 points. Now using this concept, we see that at the place of x1 we have 0, at the place of y1 we have 0, and it goes to the point x2, comma y2. So x2 is 1, y2 is 0. Now we can find the parametric equation of the curve C1 by using this concept. So let us do that. So using this idea, the parametric equation x will be equal to, that is parametric equation of the line segment C1, where x will be equal to x1, that is x1 is 0, plus t multiplied with x2 minus x1. So t multiplied with 1 minus 0, which is 1. Therefore, the parametric equation is x equal to t and y is equal to, here 0 plus t multiplied with 0 minus 0. So it will be 0. Therefore, the parametric equation of the line segment C1 is x equal to t and y equal to 0. And we know that the complex variable z is equal to x plus iy. Now when we substitute this x and y over here, we get the complex variable z to be equal to, now x is t, y is 0, so z is equal to t. And from this we obtain, on differentiation, dz will be equal to dt. So on differentiating this with respect to t, we get dz to be equal to dt. We know that t ranges from 0 lesser than or equal to t, okay, lesser than or equal to 1, because it goes from 0 to 1. So if you see here, x is 0 here and x is 1. So therefore t ranges between 0 and 1. The reason is when x is 0, t is 0. And when x is 1, t is 1. That is the reason. So now we shall evaluate the required integral. The required integral is integral over c1 modulus of z the whole square dz. So that is equal to, the limit for t is 0 to 1. And then modulus of z the whole square. Z is t. So t square we will have. And then dz is equal to dt. Now on integrating this we get t cube by 3, because the integration of t square is t cube by 3 between the limits 0 to 1. And that is equal to, applying the upper limit and lower limit, upper limit is 1. So 1 cube, which is 1 only, 1 by 3, minus the lower limit. Lower limit is 0. So this whole thing will become 0. So we need not write it. Therefore, we have evaluated that the integral over the line segment C1 is obtained to be 1 by 3. So this is the first line segment, the value of the given integral in the first line segment. In a similar way, we shall find for the second line segment, that is C2, which is between 1 comma 0 to 1 comma 1. So we will write the same required for this line segment C2. So in a similar way, we are going to find for our integral over C2 modulus of z the whole square dz, for which first we should know the line segment C2, which is from, if you see, the line segment C2 is from A to B. So we shall write these coordinates also. So the line segment is from A to B. So which is from 1 comma 0, because A is 1 comma 0 to B is 1 comma 1. So we see that the value of x1 y1 is 1 comma 0, x2 y2 is 1 comma 1. So after this we have to write the parametric equation of C2. Just now we saw that the parametric equations are given by x equal to x1 plus t multiplied with x2 minus x1. So here when we substitute, x1 is 1, x2 is also 1. So when we substitute, x will be equal to, this is 1 plus t multiplied with 1 minus 1, 0. So therefore the first parametric equation is x is equal to 1, and the next parametric equation, y is what? y1 plus t multiplied with y2 minus y1. So when we apply in this, y will be equal to, what is y1? It is 0 plus t multiplied with y2 is 1. 1 minus 0, 1. So therefore the parametric equation is x equal to 1 and y is equal to t. So we are done with the parametric equation of the line segment C2. And we know that the complex variable z is equal to x plus iy. So on substituting this, we get z is equal to 1 plus I multiplied with y is what? T. So it. Actually we want modulus of the z the whole square. So modulus of z, we know that it is equal to square root of 1 square plus t square. Squaring on both the sides, modulus of z the whole square will be 1 square is 1 plus t square is t square. So the square root gets vanished after squaring on both the sides. So this is what we obtain as modulus of z the whole square, which is 1 plus t square. Now from z equal to 1 plus it, we can find dz. So from this, dz will be equal to, what is the differentiation of 1? It is 0. And the differentiation of it is, I is a constant, so I multiplied with differentiation of t is dt. So this is dz that we have obtained. And as we saw previously, the value of t will range from, now y is equal to t, isn't it? So now when y is 0, t will be 0. When y is 1, t will be 1. So the value of t ranges from 0 to 1. Now we shall evaluate this integral c2. So therefore integral over c2 modulus of z the whole square dz will be equal to, the limit is from 0 to 1. And what is modulus of z the whole square? It is 1 plus t square. And what is dz? It is equal to I multiplied with dt. Now this I is a constant which can be taken out, and 1 on integration gives us t, and then plus the integration of t square is t cube by 3 between the limits 0 to 1. Now we shall apply the upper limit and lower limit. So this will be equal to I multiplied with, upper limit is 1. So 1 plus 1 by 3. And the lower limit is 0. So these two terms become 0. So this will be equal to I multiplied with, the LCM is 3. So 3 plus 1, which is 4. So therefore we have obtained the second integral, value of the integral over the second line segment C2 to be equal to 4 by 3i. In a similar way, we shall find the value of the integral for the line segment C3. Now in order to evaluate the line segment C3, we should first know what is the line segment C3. The line segment C3 is this, that is BC. So it will be 1 comma 1 to 0 comma 1. So let us write that. Now using the same concept that we had previously, what will be the parametric equation of C3? Now this will be taken as x1, this is taken as y1, this is x2 and this is y2. Therefore the parametric equation for x will be equal to x1 plus t multiplied with x2 minus x1, which is 0 minus 1. So we see that the value of x will be equal to 1 plus t multiplied with minus 1. So therefore x is equal to, the parametric equation for a C3 is x is equal to 1 minus t. Another parametric equation for y, so that we will find. So y is equal to what? y1, which is 1, plus t multiplied with y2 minus y1, which is 0. So therefore y is equal to 1. So these are the parametric equation for the line segment C3. Also we know that the complex variable z is equal to x plus iy. Now when we substitute this, z will be equal to 1 minus t plus I multiplied with 1, which is I. So this is the complex variable. Now from this we can find modulus of z, which will be equal to square root of 1 minus t the whole square, so real part, plus the imaginary part square, which is 1 square. Now squaring on both the sides, this will become modulus of z square is equal to, the square root will get vanished and we will have 1 minus t the whole square plus 1 square is 1. Now we will expand this by a minus b the whole square formula. So it will be 1 minus 2t plus t square plus 1. So this 1 and 1 gets added up and we get this as 2 minus 2t minus t square. So that is modulus of z the whole square that we have obtained. Also since z is equal to 1 minus t plus I, from this we can say that dz will be equal to, differentiation of 1 is 0 and differentiation of minus t is minus dt, and I is a constant, so it vanishes. So therefore dz will be equal to minus dt. So now we shall evaluate the required integral, that is integral over C3, and then modulus of z the whole square can be written as this. So it will be 2 minus 2t minus t square. And what is dz? It is negative dt. And we know that the integral is between the limits 0 less than or equal to t less than or equal to 1. The reason being, when x is 1, the value of t is 0. When x is 0, the value of t is 1. So that is the reason. So the limit, so this will be equal to integral 0 to 1. This negative sign we can write outside, and and this will be 2 minus 2t minus t square dt. Now we shall integrate it. So that is equal to minus multiplied with the integral of 2 is 2t minus 2, the integration of t is t squared by 2, minus the integration of t squared is t cubed by 3, and this is between the limits 0 and 1. So evaluate this carefully. The integral of a constant, that is 2 dt it is actually, so the integral dt is t. So be careful with that integration, and that is equal to minus of applying the upper limit, that is putting t equal to 1. Here you get 2, and this 2 and 2 gets cancelled, and t square, that is 1 square is 1, minus, and t cube, so 1 cube by 1, which is 1 by 3, and lower limit when you apply it becomes 0, and so that's equal to negative 2 minus 1 is 1, so 1 minus 1 by 3, which will be equal to minus, the LCM is 3, and 3 minus 1 is 2. And there is a slight correction here. It is 2, 1 plus 1 is 2, minus 2t, and this one is plus t square. By mistake I have written minus. So this will be plus, and so here also plus, and here plus, here also, and here also, because of which this will be plus. So 1 plus 1 by 3 will be 4 by 3 actually. So the value becomes minus 4 by 3. So kindly make that correction. So we have evaluated the third line segment as minus 4 by 3. Next we have to evaluate one more line segment, which is C4. So now we are going to evaluate the last line segment C4, which is this OC. Okay, so how can we do that? We will consider the coordinates 0, 0 and 0, 1. So C4 is the line segment CO. And what are the coordinates? The coordinate C is 0, 1, 2, the coordinate 0, 0. So here this will be x1, y1, this is x2, y2. Now we shall write the parametric equation for the line segment C4. So it will be x is equal to, now if you apply the formula x1, so 0 plus x2 t multiplied with x2 minus x1, so which is also 0, so 0 plus 0, so it will be x is equal to 0, and y will be equal to y1, so 1 plus t multiplied with 0 minus 1, which is minus 1, so it will be 1 minus t. So these are the parametric equation of the line segment C4. Now we know that z is equal to x plus iy, and so z will be equal to, this is 0, I multiplied with 1 minus t. Now on differentiation, what we will get? So from this, the differentiation of z with respect to t is dz is equal to, I is a constant which is in multiplication, multiplied with differentiation of 1 is 0, minus the differentiation of t is dt. So therefore we have obtained dz to be equal to minus I dt, where this t lies between 0 and 1, because when y is 0, t is equal to 1, and that is this one, and when y is 1, okay, when y is 1, t is 0. So since y is 1, t will be 0, and when y is 0, t is 1. This is how we got the limits. Also from this, since z is equal to, we will say write it as real part and imaginary part. It will be I multiplied with 1, and the real part is 0 here. So the imaginary part is 1 minus t. So we need modulus of z. So modulus of z will be square root of, real part is 0 and the imaginary part is 1 minus t square. Okay, now taking square on both the sides, modulus of z squared will be, square root will vanish, we will have 1 minus t the whole square. In fact, while expanding we get 1 minus 2t plus t square. Now we shall substitute each of this in the required integral. So therefore, integral over C4 modulus of z the whole square dz will be equal to integral over, the limit is 0 to 1. So 0 to 1. And modulus of z the whole square is 1 minus 2t plus t square. And what is dz? It is minus I dt. So multiplied with minus I dt. So that is equal to, on integration, and this minus I is a constant which can be taken out of the integral, and the on integration this becomes the integration of 1, that is 1 dt will be t minus 2. This t on integration gives us t squared by 2 plus the t square on integration gives us t cube by 3 between the limits 0 to 1, and that is equal to minus I. Upper limit when you apply it will, and this 2 and 2 gets cancelled. Upper limit when you apply 1 minus 1 square is 1 only. So 1 minus 1 plus t cube, so 1 by 3. Lower limit when you apply everything becomes 0. 1 minus 1 is gets cancelled, and we get minus I divided by 3. So this is the value of the last integral. So we have evaluated all the 4 integrals. Now in order to find integral over C, we shall add all the 4 integrals. That is, you know that integral over C is equal to integral over C1 plus integral over C2 plus integral over C3 and plus integral over C4. So this is what we are going to do. So therefore finally we have integral over C modulus of z the whole square dz is equal to, what is the value of the first integral over C1? We obtained that to be equal to 1 by 3. So integral over C1 is 1 by 3. So let us take and write this. 1 by 3 plus the second integral, integral over C2, that we have obtained as 4 by 3i. So we shall take and write this. 4i by 3 plus the third integral. We have obtained that to be minus 4 by 3. So we shall write that minus 4 by 3. And the last integral we have obtained to be minus I by 3. So minus I by 3. Now we shall add everything. We see that LCM is 3, which can be written like this. And we have 1 plus 4i, and this is minus 4 minus I. And what is 1 minus 4? It is minus 3. And what is 4i minus I? It is plus 3i divided by 3. Now 3 can be taken in common. So 3 multiplied with minus 1 plus I divided by 3. So 3 and 3 gets cancelled, and hence we have obtained integral over C modulus of z the whole square dz to be equal to minus 1 plus I. So this is the required integral that we have to evaluate. This problem is one of the significant question which has appeared in the previous year question paper also. So kindly go through the problem step by step patiently. So therefore we have shown that the integral over C modulus of z the whole square dz is equal to minus 1 plus I. So hence we have shown. So I hope you would have understood this problem to the best of your understanding. Kindly follow the upcoming video lecture for more problems under this topic. Thank you.